There we go. Okay, so this is a little bit different than things I've talked about with managing complexity or working with complexity, rather, uh, because I'm presenting it with a different angle that we're doing with Amplio, but it more or less is kind of the same message, but I think it adds a little bit of clarity to what we're trying to accomplish with it. So, um, what what I've got here is this talk is about a pragmatic way to deal with complexity, because I think the way most people deal with complexity is not very pragmatic. It's more at the effective things. And this is me, for those of you who aren't familiar with me. I've been around quite a bit of time. I used to be very technical. I still am technical, actually. I realize I see a lot of conversations about tests first and stuff like that. That is, we had greater clarity on what all that was back in 99 to 2005, and it kind of got lost with the ascension of Scrum as the primary way of doing things. Um, but I haven't been programming for a while, but what's kind of maybe distressing is the fact that things I knew 20 years ago or pretty widespread 20 years ago seem to have been lost now. I'm not quite sure why that is. Well, I think I do know, but I'm not going to speculate on that. But I've been in the agile space a lot, people, because the reason I focused on the workflow and stuff over now the last, I guess actually 12 years is simply because there are other people out there who are dealing with the technical side. And there are a lot of really great people dealing with the workflow side too. You know, Wolfram Mueller, Steve Tendon, Niels Malatoy. There's quite a few, but they haven't put together what I would call a complete broad system that Amplio is. So that's why I keep plugging away and focusing on that. Um, the As you can see, I've written quite a few books, but I want to create the context for this. This is not just a talk on complexity. It fits into Amplio's approach of what I call value by design. And the point of value by design is you don't just follow processes, you've got to look to see what works for you in your situation to create more value. And that's just a phrase I use. Amplio is kind of my way of doing it, but value by design is a generic. How do you create this? You know, theory constraint has an angle on it, lean has an angle on it, flow has an angle on it. I use all three of those plus human-centered development because Agile is supposed to be about people and it talks about it being about people, but it gives very little indication of how to work with people. And what's worse is all the frameworks I'm aware of ignore the effect frameworks have on people, where you can just say do it, follow it, understand, things like that. So the key for value by design is we design our systems so we can apply our resources, whatever capabilities we have, efficiently to create as much value that we can so we can meet our business objectives. Scope is important. Scopes, though, is more about the particular criteria we need for the situation we're in. Okay. And I add this last line, scope should be in line with the original objectives of the project, because one of the big problems I see is people kind of discover what the objective is while they're building it. And to me, this is kind of wasteful and not necessary. There are ways to know your objective up front. In fact, most people don't, and that's why most projects and products fail, but it's not inherent. There's another attitude I take, which is that the bottom line is Amplio does not accept being at the effect of the currently perceived reality, but looks to see how we can live within its perceived constraints effectively while working to push their boundaries. In other words, I don't accept the limitations as inherent, while I acknowledge that at the moment they are something I have to deal with. Okay. There have been so many things that I've done that people tell me can't be done. I've seen this with a lot of other people. A lot of really good consultants do things other people say can't be done. And what we want to do is recognize that what appears to be real is actually just a perception at the moment. And that is what we want to attend to is how do we push those boundaries of what we think is what we think is the limitations and go beyond them. So we can't just say, oh, we can do anything. You got to attend to reality. But at the same time, you don't need to accept it as inherently the way it is. Okay. So this is a lot of what this talk is about, because I believe complexity is really a perception problem, and we'll see this. So let's start with that. What is a complex system? Okay. So complexity refers to a state in which a system's behavior arises from the interactions of many interconnected parts. It makes it difficult to understand it, even if you understand the pieces. So you can look, oh, I understand this, I understand this, I understand this, I understand this. But it has so many interrelationships and feedback loops and sensitivities to certain conditions, it's not understandable. Now, this is very fitting with the idea of what a system is. I like Russ Akoff's talking about systems. He says systems are defined by the relationships between the components, not the components itself. So when you have so many, you can't see all these relationships, you can consider it complex. But the example he used was you could take the best parts of the best cars, put them together, and you wouldn't have a car. Now here I've got all Mercedes-Benz parts, so it becomes a car. But if I interchange better parts of other cars with this, you wouldn't have a car. Carness exists in the system as a whole. And this is maybe the first beginning understanding of why people think systems are complex and shrug their shoulders and kind of give up, because the local optimizations may not cause global improvements. Okay. And this is a key, because because you can make an improvement, you think locally, and then it doesn't really improve anything, and you wonder, oh, I guess I don't understand what's going on. So, but the reality is you've got to understand that local improvements may not improve things, not even because it's complex. That's just the nature of a system. So we have to look at this. Okay. So I want to look at what types of unpredictability there are. Okay, because that's really our issue. Complexity in and of itself is not the real issue as much as the complexity causes unpredictability, which is the real issue and can cause waste. So one thing is we can have nonlinearity. That could be some little thing happens, we're going along fine, adding weight to the camel, and then once it breaks his back, bam, we get a lot of problems. That's what's called a nonlinear event. Sometimes it's called the butterfly effect. It's been quoted in many different ways, but like a butterfly flapping its wings in Japan can cause tsunami, on the west coast of the United States. Um, some little event. Now, if you look in the world, you see these little events happening all the time. And most of the time, they don't cause any real big problem, but every now and then a little event creates a massive problem, a catastrophe. But they're just not just nonlinearity. Now, the interesting thing about nonlinearity, though, is it is predictable. You look at tensile strength. You take a bar of steel and you pull it and pull it and pull it and pull it and pull it, and then it breaks. It's nonlinear because going from, say, 2,100 pounds of pull to 2,102 pounds of pull breaks it. But actually, when you understand things like that, you can predict where it'll break. So nonlinearity is not so much unpredictable in and of itself, although it often is, because sometimes you don't know. It's that you don't see what's about to happen. So this is an important aspect to see. There's also what I call cascading unpredictability, where like a little thing happens and another little thing happens and another little thing happens, but it keeps getting worse and worse. This is one of the reasons schedules don't work so well, because they're a classic problem as a cascading failure. In other words, one person misses a meeting, and then a little bit of misinformation is missed, and then that gets spread and gets spread and gets spread, or requirements misunderstood, misconveyed. And after a while, you have this huge amount. It's like a little bit, a little bit, a little bit, but it's all big as time goes on. Okay, there are probably more than these three, but these are three that seem to come up, which is that it'd be very predictable if you could see it, but you can't see it. This has nothing to do with complexity in the sense of, oh, it's so complex, I can't understand it. It's I can't see it. Okay. So it may be I can't see it. It may be a variety of things. and maybe it builds on top of each other. So I'm trying to look at complexity, not from what it's like necessarily in the system, but notice the perception problem here as well. Are there any questions about this? I think we can all relate to this. Is there a fourth type? There probably is, but I just haven't really thought about it. Um, the interactions, actually, that would be another one. The two or three things interact in a certain way, that's fine. You had a third thing that adds some effect. So multiple interactions would be a fourth kind that actually make things work. But I suspect it follows one of these three waste structures, slowly building a quick abrupt, or we just don't see it. Okay.
Yeah, I would perhaps add something like a compounding. So it's probably included in your cascading. For example, when you analyze some of the airline disasters, it's often not just one thing that went wrong, but it's a lot of little things that
Yeah.
each of by themselves would be sort of tolerable, but all of them combined can no longer be recovered from. So you have the compounding of many little things.
Yeah, that's actually a good point. It's kind of like, yeah, compounding would be a fourth one, and compounding usually shows up as building a cascading effect and predictable, and then it goes to a nonlinearity. The
Right.
Piper Alpha in the North Sea failure was an example of about five or six things going on, and some of them were simple, and some of them were really just a little tiny thing. The big explosion that occurred there would not have happened had the divers not placed their wetsuits on the external grill, the stairway up on the outside. That's pretty minor, right? My mom used to get mad at me for not putting my clothes away. So here, 100 and plus people died because these guys put their suits on the grill. But the reason they did that, it wasn't their suits, rather, they put black mats, rubber mats down. The reason they did it is because that's where they prepared to dive, and the grills are very painful on bare feet. So they did it. The problem was that then when they had all these minor things that you said, Thomas, that caused problems, and the liquefied gas came out the door where that was. Normally, it would have just fallen through the stairwell into the ocean, and it would have caused fire, and maybe a couple of people would have died, but the whole thing wouldn't have gone up like it did, because it's when that fire occurred under another point above it, there was a pipe above it that blew up the whole thing. So yeah, so a compounding effect would be another one to have. And then what you see with a compounding effect is you see this and this until a catastrophe happens. If you want to get good insights on this kind of thing, you should look on YouTube. Look for what are called 30 seconds from disaster, where they go through this, and they have one on the Piper Alpha, by the way. They also have one on the supersonic jet that blew up. In that there were a lot of
The
problems
Concorde.
with it. Yeah, the
Yeah.
Concorde. There were a lot of problems with it, and there were a lot of little design things that happened. But again, there was a little piece of rubber that had fallen off a plane before it, that when it ran over it, it punctured the fuel tank, and then something else happened besides. Then you had a blow up. So you see these disasters, it's typically a combination of several factors. If you They're sometimes not designed into the system per se, and sometimes they are. Like Chernobyl was a failure due to a design flaw that was kind of going to happen as an accident eventually. 3 Mile Island was also design flaws, but they're interesting when you study these. You start seeing some things that are not obvious, and we'll get to that in a minute because I have studied these. Um, I don't. I think I got just interested in engineering disasters for two reasons. I'm not particularly a morbid person, but one of the things that's very interesting I noticed years ago, and I think this had part of it for me. The Titanic, when you look at it after the fact, it looks like, oh my God, how stupid could they be? That's my kind of arrogance as a teenager. How stupid can you be? Except then one time it occurred to me, but wait a moment, this was the greatest ship built in the world. It was an engineering feat. They had the best designers building the Titanic, the best, the best architects, the best shipbuilders they could find. And look what happened. So what's the lesson to learn is, I don't care how good you are, there's this stuff you don't see. And it's the arrogance that you see it all that usually is what causes the problem. And some things in the world of the physical, meaning the Piper Alpha, the Concorde, the Titanic, once something happens, it's not reversible. But this is maybe a clue. Things in knowledge work should be reversible. And that's one of the things I don't hear talked about too much. Anyway, here's another insight on predictability and unpredictability. So I got this from Don Reinertson. He said this once. I made this slide. Okay, we don't know whether it's going to be green, red, or black. We do have a high probability that it's going to be on something I didn't bet on, but that may just be karma than a real science. But see, this is what we call micro predictability. What's going to happen? But we know more money staying at the table than going away from it. That's macro predictability. Okay. So we want to recognize that just because there's micro unpredictability does not mean there's macro unpredictability. And yet you hear this all the time. Okay. And a lot of the causes of disasters and mistakes happens due to micro unpredictability. So yeah, that's a problem. Okay. So there's a belief that's important to bring in also about predictability. This comes from Ellie Goldratt in The Choice. It's one of my top 3 or 4 books to read. The other 2 are Timeless Way of Building by Chris Alexander, um, which ironically I'm starting to think is less critical for process work because I've switched into the jobs to be done model. But and then the other one is The Obstacle is the Way, which is a book on Stoicism, although I actually don't believe Stoicism is necessarily the right spiritual thing to do. There's some really good insights in the book. And my 4th book would be Principles of Product Development Flow by Don Reinertson. But here's the question. Consider how size, delays, capacity, visibility, or lack of it, handoffs interrelate with each other. See, he's suggesting that there actually are just a few factors that come into causing this. This is something in the Amplio foundations, and I've got videos on this, so I'm not going to go into this in depth. I've got a link at the end. If you want to say, well, this sounds great, Al, but I need more, that's great. I'll give you more, but not this session. I've got at least a day on this stuff. There are good videos, good articles. And they're not so much just my opinion, although I agree with them, obviously, since I made them, but they are things that people like Akoff, Goldratt, Gill, Reinertson, Deming, others also have put forth. In fact, I've gotten it from them. Um, the inherent simplicity idea is something I've been searching for literally, oh, I don't know, from around 2016 to 2006, rather, to 2019. It's funny how I can remember these dates. I remember an event and I remember when that happened. And the event was when at Net Objectives, we were having difficulty working with 3 or more teams. That was Agile at Scale, by the way, in 2005, 2006, was 3 teams. Nobody knew how to do it. Scrum had talked about Scrum of Scrums, which we had tried. It didn't work for a variety of reasons. And our president, Alan Shuttle tried something that worked. And it was kind of flow, kind of lean, because he knew lean, I knew lean. And it was like that impressed me so much. I realized there's got to be a way of discerning what's going on in all this. And I would get closer and closer, but the way I'd get closer was this. I was here, and then 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 I was here. And from 2017 to 2019, I was very frustrated because I couldn't get to it. And just before I joined the PMI, which was in 2019, I read The Choice and it was aha. It's this inherent simplicity that if we dive deep enough, there are very few elements at the base, the root causes, which through cause and effect connections governing the whole system. Now, what he doesn't say is that we can see them all. I immediately jumped, okay, great, we can figure it out. No, a lot of it's obscured, but they do exist. So the question is, what do you do with it? What do you do with this knowledge? You know, can you look forward? Can you not look forward? These are questions that some people have arrived at answers to that are impenetrable in their mind. So before I go into what to do, I want to look at what a little bit about complex systems are. So how can you tell if you're in a complex domain? Well, here's the quick answer. You are. If we view complexity as, go back to that original definition, a state in which a system's behavior arises from interactions of many interconnected parts making outcomes. I'm going to ignore that part, but just outcomes difficult to predict. I'm saying I don't care where you are, there's always difficulty to predict things, even when it looks very simple. So I just think you are, basically. Now, there's a longer method. Look at the number of relationships. Have you done this before? What are the number of things that can go wrong? What's the degree of visibility you have? We'll see why visibility is important very soon. The point is, if you can look at these, how many nonlinearity things are there? That's the other thing. Okay. If you've got a lot of this, then you're in a more complex, there's more complexity present. Okay. But I would suggest that complexity, how we look at it, makes the difference. Systems thinking tells us systems are about relationships. Let's look at the type of relationships we have. Okay. So you can do it one of two ways. You can look at a state you're in, but notice this is states, not relationships. So I don't like looking at it this way. I don't like saying we're in one domain or the other, moving it around. I prefer to say wherever we are, we have a combination of complex relationships, nonlinear, complicated, simple. Simple means we see it directly. Complicated means there's several factors. That complexity and nonlinearity cause different problems. Complexity hides the nonlinearity stuff, as we talked about. If you handle simple and complicated, it doesn't cause problems, but we also saw sometimes we don't see it's visible. Okay. So the idea is maybe we can manage the things we see, manage the things we know, and that will unobscure the things we don't. Okay. So sense making is a general approach to trying to figure out how to understand something. There are at least a dozen sense making systems I'm familiar with, like Carl Weeks. I forget the name of the book. It was he wrote a book with somebody else. I can't remember her name right now. Then Margaret Wheatley has a sense making. Dave Snowden has a sense making system. They're all different sense making systems. How do we make sense of reality? This is, you could say, the Amplio sense-making system if you want. Uh, but I'm not so much trying to worry about the sense of it as I am about what can I do with it, because I'm kind of very pragmatic and action-oriented. And this is another great book I read. Actually, I remember listening to the Audible account um, and it's why our systems fail and what we can do about it. Okay. And while I'm reading this or listening to it, I remember walking on the beach listening to an audio tape of it. It just hit me that what's going on, that nonlinear events just don't happen in when like in the Piper Alpha, the Concorde, the Titanic, and we could look at those three. They all have a potentially nonlinear event. Like in the Piper Alpha, it was these rubber mats. They've been moved. In the Concorde, if that rubber piece on the ground runway hadn't been there, or if it hadn't punctured the gas tank, I mean, it could have popped up and not hit the gas tank. There's only one of them. Or there was something else that severed a wire that was loose because of the puncture that then sparked the fuel. That's why it caught fire. It's amazing. Fuel does not catch fire automatically. It needs a spark or a flame or something. So you have this potentially nonlinear event. Why? Because typically things just don't go a little bit by a little bit by a little bit. Sometimes they do. But even then, they usually are sparked or started by a nonlinear event. Okay. They're coupled with other events that can cascade. There's a lack of visibility. This was actually the source of me understanding this. This was also around 2018, 2019. But this is the key, the inability to fix the problem. If somebody could have crawled out on the wing of the Concorde after the tank got ruptured and patched it, it wouldn't have blown up. But you couldn't do that. If 3 Mile Island, the lack of visibility there was a sensor, was misreading. If they had known it was misreading, if they could have seen what was happening, they wouldn't have done things that actually caused the problem. Okay. Chernobyl had an actual design problem because of they were trying to cut costs and it didn't have a containment dome. But even there was a lack of reversibility because of the design. So sometimes the reversibility or lack of it is due to physical events or the design of the system itself. So this gives us a clue what to do. Maybe we need to look for cascading events. We need to have visibility. We need to be able to reverse something. So be clear what I'm talking about here. I am not talking about dealing with complexity everywhere. I'm talking about dealing with complexity in product development. And this is also something I find poor logic. A lot of times people justify complexity in product development by looking at complexity in the world. No, they're two different things. Complexity in the world is very difficult to deal with. Complexity of an individual is easier. Multiple at a team is a little harder. Knowing what the market is a little bit harder, but it's not all you. It's not a complexity is not an homogeneous issue, and yet when you hear people talk about it, they talk about it that way. And I say they talk about it that way because they'll talk about complexity in knowledge work, then they'll point to something that's complex somewhere else, and then they'll come back and say, "Oh, see, this is what's different." Now, I actually, sorry, I'm going to get distracted here, but it's because there is actually, I'll just put this right back up. I can find this. I want to show you a picture. I thought about putting this in and I decided, um, here. This comes from a book called Normal Accidents. I thought this might have gotten too theoretical, so I didn't put it in, but I just realized this would have been a good thing to do. So this comes from Charles Perrow. He did the study after 3 Mile Island, and he got interested after he did the study of 3 Mile Island about complexity, and he's the one who basically said that accidents in complex systems are bound to happen in normal. And what he talked about though is complexity versus linearity, and he talked about loose coupling versus tight coupling. So you might notice a nuclear plant, the problem is it's complex and it's tightly coupled. And he didn't talk about visibility, but you can see nuclear plants physical. You don't always see everything that's going on. But see, what's interesting is to notice R&D firms down here, like knowledge work would be down here. Why is that? Because yes, it's complex, but it's loosely coupled. In other words, you can separate things. So I'll add this slide to the notes, but this is an important notice that it's not homogeneous. The degree of complexity changes based on where you were. So when people talk about how this is so impossible, they're ignoring that, well, it isn't for what we're doing. Okay. And notice also, it's not like these domains are totally complex or not complex. They have different factors making them up. So this was a very interesting book to read. It's a bit esoteric, but if you like things like that, it's actually pretty good. I really enjoyed going through that. Okay, so how do we deal with all this? Okay, so the first thing is to recognize that complexity is a perception problem more than a real problem. In other words, the system looks complex, but after a while, we can understand what's going on. Now, some people think you can only understand what's going on after the fact. I don't quite agree with that, but you can see what happened. That's why you could, like Thomas, you said all these different things happen. You can, in fact, understand once it's all known and has happened. So it's really it's not that the system in knowledge work necessarily is complex as much as our perception. Now, some systems are truly complex. We can never figure them out due to nonlinearity. The three magnet problem is one, weather is another, but we're not dealing with the weather in the three magnet problem. Okay. If we could see everything, we wouldn't have as much problem as we do. So we're now setting up that maybe it's there, but we don't see it. Oh, how do we see it? Instead of accepting we can't see it, which obscures all possibility, say, well, how much can we see? So I'm not saying we can see it all. I didn't say that, but maybe we can see more than we do. There's this negativity in on LinkedIn anyway. I wrote a rant yesterday. I just got so tired of somebody of all places from ThoughtWorks talking about how you can't do certain things. I actually now, after he responded to me, I think he didn't mean that you can't, but that's what he said, was that people don't. Well, there's a big difference between you can't and you don't. And I get really irritated when people say you can't do things that I've done or I've seen other people do. And you can stop systems from degrading. How do I know? Because I built a software development system from 1980 to 1983. This was my first failed business. We built something amazing. It was truly amazing. It was it was like what the San Francisco project was supposed to be, only I succeeded with it, but not marketing wise, because I didn't know how to market back in that day. But I used that from 83 to 96, building about a dozen vertical applications. And over time, it got better every year. Why? Because I took the attitude when I made a mistake, I would look to see why, and I would fix the system to guide me not to. I did that. It was like stupid not to. It was like this thing's going to keep happening. Why? Because my brain's limited. You know, there's Shalloway's law. When n things need to change, Shalloway will find, and n is more than one, Shalloway will find at most n minus one things. I know that about me. I'm just what happens. Now, I could take courses on how to memorize better and all that, but I'm not hopeful on that, especially now at my age. But even back then, when I was in my 20s and 30s, I wasn't that hopeful about it. So I created a system that would find things for me or conventions that would avoid the problem. Anyway, getting off track there. But it's like we want to look at what we can do, not what we can't do, while we recognize our current limitations. I'm going to say that again. This is my philosophy with this. Recognize the difference between what we can do and what we can't do at the moment. Recognize there's something inherent there, but move forward. So I'm not saying be crazy. Visibility, we've already stated, is a key, and reversibility of failures is another one. Okay. Any questions up to this point? Because I'm about to change gears. You see, there's a problem here. We're not saying we can see it all, but we're saying we can see some. Okay. So I read a jobs to be done. I want to talk about jobs to be done for an interesting reason. And it's the shift to the customer, the person who's using it. These guys are about marketing. Okay, so they wrote this. I read Ulwick's book first, and I'm still reading Christensen's. I like Christensen's better because it's broader. They published it at the same time, October 2016. I think Ulwick is the guy who coined the term, but it's hard to say. They don't acknowledge each other directly. Um, Ulwick is the guy who also did, rather it was Christensen, did the Innovator's Dilemma and stuff. So both these people have been in this field for a long time. But what's interesting is Ulwick talks about kind of products you make for people to use, like a service or a physical product to use. And Christensen extended it. And in other words, he thought about it as a like he talks about a milkshake actually. What's the job of a milkshake in the morning? You know, what is it serving? What's the job to be done? I thought that was a little odd. So then gave me the idea maybe I could extend it myself. So I'm going not quite consistent with them, but I want to explain it. So the job to be done is a specific outcome or change that a person, team, or organization seeks to achieve in a given context, independent of any particular solution. So I'm already maybe shifting this a little bit because they mostly talk about individuals, but their definitions would work with teams or organizations. It describes the process of attempting to transition from a current situation to a preferred one, but being hindered by constraints. By the way, just as a side note, those of you who know Toyota Kata, doesn't it almost sound like a guidance, like a kata to go from one place to the other? Interesting. Jobs to be done thinking focuses on understanding these outcomes to guide innovation, product design, and value delivery that align with the real world needs. So I'm going to say that I'm not talking about stakeholders like using a product necessarily. That is one type, but I'm going to define two. I actually, in Amplio, we have four types of stakeholders, but in this conversation, I'm only interested in two of them. That's consuming stakeholders, those people who actually use whatever you're doing, and value adding, those who create what you're using. The other two are constraining stakeholders like the federal government or something like that. And the sponsoring stakeholders, who's paying for it. Okay, so let's look at this. So let's look at how I'm extending this. So you'll see some of what I'm talking about here, but I want to make clear I'm extending this. Okay. So you have your prospective consumers, you know, job to be done specific. That's what I just wrote. You've got to align with real world needs. You're building something for them. Could be a software product, could be a pressure cooker, could be a milkshake that they can have to kind of while they drive. It's neat and fills them up. Kind of entertaining, keeps you busy while you're driving, so you're not bored. So that's the standard way of doing is that development teams can use a jobs to be done approach to discover what jobs need to be done. So they'll buy them. Okay, these are the value adding stakeholders whose consuming stakeholders they're building for that got cut off. Is that clear? This is the standard way of thinking about it. Now, what I do with Amplio and success engineering, what I do is I'm trying to help these people, you all. I'm not selling you a service or a product per se. I'm selling you Amplio in Amplio University. So I'm trying to help the development team. So what I'm doing here, so these guys are value adding stakeholders to the consuming stakeholders. But what I'm creating an improvement approach. We and the aces that are here, we interact and we build it together. We're value adding stakeholders. Our consuming stakeholders are development teams. So some of you on this video are wearing both hats. You're learning, you're a consuming stakeholder, but you also, the way we do Amplio University, you're also value adding because you're helping me create Amplio all at the same time. That's actually kind of interesting when you think about it. That when you're both a developer and a prospective customer, you know more. You've seen this, by the way. You've seen many people got into software development because they were consuming stakeholders. They couldn't find someone to give them what they wanted, so they figured it out themselves. Why was that? Because they knew the jobs to be done, because that's what they were trying to do. By the way, this is a big clue. Development teams should get as close to that model as possible. They should understand what's going on. Few do. And Agile, if anything, has made it harder. So I would say we're value adding. Amplio is value adding and to the development teams. And this is this 3 level. So Olwick and Christensen are here, and I've added this as an extension to it. Same type of thinking, but an extension. And I think this is okay because there are already about 5 models of jobs to be done. I'm not putting them up here due to time. But there are other views. Some people look at this, oh, jobs to be done personal. How do you grow as a person? Things like that. Same thing. Okay. So now we've talked about dealing with complexity. So if I'm taking this, remember, I've got this dual level now. I've got this value by design. I'm trying to design the system, and I've got this jobs to be done. Then how do I work on it? Well, the idea of jobs to be done is it always has a stakeholder present. In other words, these are not generic things. Like I mentioned, the shake Christensen talks about. He was not just selling shakes to anybody. He discovered that people in the morning who had long drives were buying shakes, milkshakes. That basically the purchase of the milkshake in the morning was the job to be done was cleanliness, keep me fed, and entertain me while I drive. In other words, they wanted something that took a long time to eat. So who's the stakeholder? It wasn't anybody for breakfast. It was people who had long commutes. So they tailored things to make it easier. They put in a milkshake drive-through to make it easier to get your shake. Things like that. What's the context? What's a default implementation? Why do you want a default implementation? Well, it first of all serves as an example, which would be good, but it also means if I just want to get started, I've got something to do. How capable are you now so you can run diagnostics on it? What other considerations must you attend to? So let's go through these. So I'm going to do the Amplio Jobs to be Done playbook regarding complexity. Let's talk about that since I said that, right? So these could be individuals, teams, or organizations creating value. I actually view all these as kind of having to solve the same problem. We're working in a complex domain, which is yes, we are. Problem development, product development is that. Okay, so here's another way of telling you if you're in a complex domain. See, I don't actually worry about it like I gave you the close. There's this thing called VUCA. This came out of the Army somewhere in the 1980s. 86 is what I remember the year, but it was in the 80s. VUCA stands for volatility, uncertainty, complexity, and ambiguity. If you want to know more about complexity, am I in a problem domain? Because I hear a lot of people say, oh, I like this because it tells me I'm in complex and you can talk to people. Well, managers, executives, stakeholders, they understand there's volatility, uncertainty, complexity, and ambiguity. How much of them are there? So if you want to make sure that people understand it's not simple, you can talk about VUCA. This is something by Carol Maze. I when she was at an earlier company, I think it was Gearstream, Net Objectives and Gearstream collaborated together, and she was their kind of tech person. She's really great. She's really, really, really smart. Uh, and she had created this thing. Uh, I forget now what she called it. I'm sorry, I don't have the name, but that she's the one who did it anyway. So volatility, uncertainty, complexity, and ambiguity. And she had this model that says, well, this shows you what you're vulnerable to, what's unexpected, what consequences and what assumptions, and what you must do. Vigilance, understanding, containment, and agility. I mention this now because I want to show how she also doesn't think you're at the effect of this, but there are things you can do about it. And you can tell you're in problems without having to make a big model about I can't do anything about it. Because sometimes the biggest advantage of how to deal with complexity is just simply knowing you're in it. You can't just lay it out. Well, this is an easy way to do it without getting into any theory about complexity. Notice this stands on its own. Anything I said before this, you don't have to believe. And it's been around for 40 years, almost 40 years, a long time. In and of itself, it doesn't say exactly, and I can't remember now what her model is, but she's a good resource on things. Okay. So, what's a default implementation of the playbook? In other words, how am I saying you should deal with complexity? That's why you're here. And I know I've done 2/3 of the talk already and I'm finally getting to it, but the reason is if you don't understand your problem, how do you expect to get a solution? I'm trying to understand their problem because I believe the problem of complexity has been misinformed mostly and limited by constraints. I'm not saying it's an easy thing to deal with, but it's fairly straightforward. This is basically what you do. You remove delays in workflow to achieve quick feedback. This visibility. Make changes reversible. This is good design. Now, how does this impact things? Remember this nonlinearity? Well, maybe if you see it's going like this and it's reversible, you find it here and not here. What about this one, the cascading effect? Maybe you find you've got a problem here and not here. Do you see how visibility has a lot to do with it?
Mhm.
You see it. Feedback is visibility. Feedback is how you see the world in knowledge work. This is one of the problems with this idea that we have simple team boards, which are just, oh, here's what's ready, here's what we're working on, and here's where it is, because you can't see it. It's just not enough information. This is the visual controls are not visual controls, information radiators, as that would be called, is too limiting. What you want is a visual control. That's something that shows you the work, something that shows the agreements, and something that shows you how it's going. This is one of the things that's a problem with Jira, by the way. Most people don't seem to notice. Jira, the way it's used, typically tells you what's happened, but it can't tell you quite, and it can tell you what's in play, but it doesn't tell you this type of information. You need to see it because it's based on things happening as opposed to the time things are happening. See, that's where you see this stuff when it's a factor of time because we talked about delays. Jira doesn't track that. No, it can. It can. I don't know. I don't know how to do it myself per se, but I remember talking to a woman, oh, a long time ago, like 15 years. I don't remember exactly, but it was a ways back. And I made some comment about how Jira had these limitations. And she said, no, it doesn't. And I said, oh, tell me more. Okay. And then she told me more. She actually turned out to be a fairly advanced Jira administrator, and she understood delay and time frame was important. And she set up the system based on the equivalent of our quickest valuable releases and time. And I said, oh, that's cool. So all people complain about Jira is because it's being configured improperly, and you could blame Atlassian for that. They are actually making changes, by the way. But you could also blame most of the agile systems that ignore all this stuff. They don't give you the theory for it. Anyway, so there's more than the default implementation I talked about. There's this stuff, score. I'm not going to go through this in detail, but but this is what we're building out. Now, right now, to be candid, Amplio is based on what we call capabilities, which is a bit abstract. So I'm switching into the jobs to be done playbook because it gives you in this situation with these people, these are the things I can do. Now, all of these considerations I do talk about somewhere in the Amplio system. A lot of them happen to be in like the diagnosis system we use. You can see how these considerations, maybe I should run a diagnosis before I come up with a solution. So if you're unhappy with me, and I'm not saying you shouldn't be, but if you're unhappy with me about not giving you the details, then I would say, yeah, but notice this is only useful if you're going to run a diagnosis. And most people don't bother running a diagnosis. So at least give me credit for noticing you should run a diagnosis. And then don't take an approach that doesn't run a diagnosis because it's just not a good thing. But here's some insights. When you violate first principles, things will get worse. Working on too many things, and these are something I do have a lot. I can just mention a whole bunch of them right up front. Um, you know, it's like working on too many things, having too much delays, having too big systems, not having visibility of the work. These are first principles. Things will get worse. And the thing about first principles, though, it's not like you fix one, it fixes everything. Like if you've got a ship that's got 5 holes in it and you plug one, that doesn't mean the ship's not sinking because you still got 4. So a lot of people think that, oh, there's one thing I have to fix. And when that one thing doesn't work, they say, oh, I can't figure out what's going on. No, multiple relationships. You have to keep that in mind. Again, it may not get better because there can be limiting factors. There can be other things we're not aware of. We've got to tend to this. Managing work in process creates the ability to pivot. See, work in process has several advantages. Managing so you're not beyond work in process means you don't have too many delays. You're not overloading people. You get quick feedback and all that. But there's another thing about it. If you've got a lot in process and you have to pivot, that means all that work that's undone was wasted time. And when you come back to it, you're going to waste more time. So managing work in process effectively. XP used to have a way of saying to do it. They say, pretend you have to ship tomorrow, always. Have shippable code for the next day. In other words, they didn't care if it was that day, but today is the day. We ship it today. They wanted it to be complete. And the reason for that is then you could be interrupted. All these complaints about managers interrupting you, da, 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 da. Well, they shouldn't. Yes, it causes problems. But if it's causing serious problems, then maybe you need to be working in a different way. I've got a case study where I talked to a CEO who was very technical. He understood things. And I told him that, if it's not really urgent, wait till the end of the sprint. And he said, yeah, I get that. I'll wait if I can. But I didn't tell him never to interrupt because sometimes interruptions are good business things. I was very disappointing. I was never asked back to this company because the CTO that had brought me in wanted me to tell the CEO never to interrupt the team in the middle of a sprint. And I didn't do that. Why? Because sometimes it was worth it. And I told him that you have to be interruptible. Make it so if a business situation comes up where you need to switch gears in a day or two, that you can. There are ways to do this. They're very well known. We know how to do this 20 years ago. The fact that it's not known today, that's just another story. Okay. So lean is not about going slow to go faster. I hate that. It's about doing the right thing at the right time. Putting in time now to save time later. That's not going slow. It's getting faster feedback. So lean is the method. Lean and flow are the mechanisms to deal with complexity in a nutshell. Okay. You get less You get value faster because you have less to do and you have less waste, and the feedback provides you with what's the greatest value. This is what's so cool about this approach. There are three things really cool about this approach. One is you don't waste all the time because of the lack of feedback. The second one is you're managing complexity so you don't get hit from the side and having a lot of problems. There are actually four things. Then you're creating what's of greatest value because you can see it. But there's even another one besides all this. It's that it dealing with it the way I'm talking about creates theory and it lowers resistance in people when they understand why. This is very important. It's been demonstrated that when people are told to do things and they don't understand why, they resist it. I've got a bunch of articles. The best one I know is Semmelweis's in the mid 19th century. He figured out what was going on, but he with a high maternity mortality rate, but he had no theory to explain it. Okay, what was missing was Pasteur hadn't come along yet with germ theory, but he had connected the fact that working with cadavers and then working on having a mother give birth to a baby, that maybe that was not a good idea. And he came up with some disinfectant, chlorine disinfectant that worked. He had evidence that it worked, but people still didn't want to do it. The doctors, the administrators didn't want to do it. They didn't understand why. There was no theory. He just had evidence. This idea that evidence can drive you is a mistake. You need evidence and theory. So this is the other big thing. You can use theory to bring people's past experience to the fore. They learn faster. I've gone in when I go into places and I consult, and everybody's wondering, oh, what do we do? We don't know how and all that. And then they say, well, it's because it's complex. I say, no, it's not because it's complex. It's because you don't have a theory that I don't say this to them. You don't have a theory that binds it back to their experience. I just give the theory. I ask them questions in a way like, when was the time that you were overloaded and you didn't get feedback quickly and you caused some big problems? So they bring the evidence based on the way I question the theory. It's a key point. You can also hypothesize what'll happen in your situation, but I put fewer experiments fail. See, when you're driving your car on the expressway, you don't have 100% guarantee that if you change lanes, you're not going to hit somebody. But boy, if you call that an experiment changing lanes, I don't want to be in your car. This idea that we need feedback does not mean we don't know what we're doing. It does not mean we don't have confidence in certain situations about the result we'll get. This logic is just insane to me, but it's prevalent. You shift from failing fast to learning fast. We do better when we understand what's underneath our system. And Goldratt talks about this as the comfort zone has less to do with control and more to do with knowledge, or in his case, he meant lack of it. Okay, removing delay. This is the answer, and creating visibility is the key. There are two cycles. Too much work, delays in workflow creates work. This gets worse and worse and worse. Work within capacity, get quick feedback, eliminates waste. It's effective and that solves the complexity problem. You're getting 4 for 1. What a deal. Solving the complexity problem, finding value. People understand and don't resist. And you go faster with learning. I mean, notice the difference though is if you say, I can't understand what's going on, instead of I have a problem in understanding and how do I go about it? One is empowering and one isn't. Again, this is one of those simple things in a complex environment. Work on smaller things. We all know this from Agile. This is nothing new. Okay, so a quick review. Complexity can be dealt with in a forward-looking manner. Okay. How complex a system is, it's a perception problem. You do not know. And the idea is to turn it from being complex to being less complex. And that there is a way to do that by looking forward to it. We can take advantage of what we know to lower the risk and waste that we might otherwise have. The key is eliminating delays in our workflow. That gives us feedback and act on it. See, software development by its very nature is not very visible. See, this is the interesting thing. In building buildings, you don't have very good reversibility. In building things in the physical world, you don't have much visibility. I mean, excuse me, you have visibility, but you don't have reversibility. But in software, you have visibility. You don't have visibility, but you do have reversibility if you build it, and you can create visibility. And that's the key. Doing this improves our systems. Okay. So I told you I left a lot of stuff out. Here's the link. This has this will take you to, like I said, a whole bunch. In fact, I'll just link on it right here. This is the Amplio Foundations. There's axioms, there's articles, there's each one of these is an hour long. So there's a lot of good stuff if you want to delve into it. More than welcome to. Okay, closing. Actually, this timing is pretty good because we have the 30-minute after this. I put this up here. I do now on-site consulting, or on-site could be Zoom consulting with free follow-up training. We give a credit. By the way, my ACEs do this as well. If you get a consultant in the ACE program, we give a credit for people to be in Amplio University. One of the problems I see in the world of consulting today is somebody goes in who's really good and gets stuff done, but then they leave and nobody else is really trained because you don't have a training budget. So we figured out how to work that in. Um, the ACE program, which is the full thing, it's $1,200. I realized another advantage to this, by the way, just the other day. I was seeing a lot of people talking about all these conferences that were coming up, and I realized if all ACE, Amplio University was a conference, it'd still be a deal because it's kind of like that a little bit every week. Anyway, so let's see, it's 8:58. We got 2 minutes for questions here. Then we're going to take a 1 or 2 minute break. And then we got the 30-minute after this. So questions. That was a lot of stuff I gave you. And they can be light. I mean, if you're just wondering about something, it doesn't have to be this big question. What are you not sure about?
Oh, good morning.
I'm sorry, what?
Can you hear me?
Is that you, Daniel?
Yes, sir.
Yeah, I can hear you.
Yeah, sorry. I was a little bit absent because regulatory issue we hear that we were running. But the last thing, I was interested in the last thing. When we are saying software development is not as visible because of its nature or something, it is compared with what? I mean, compared with, I don't know, construction or maybe another like marketing or so.
Here, let me show you what I mean. I'll show you with a picture.
It's because I work in that world my whole time, so my whole life. So
Um, just a second, I'm looking for this. See, in the physical world, as you build things, it's kind of interesting because in the physical world, as you build things, you can see what's going on. But when you're running them, you often can't see what's going on. So it also that has a lot to do with visibility kind of shifts somewhat. Like here's an example in the physical world while you're building it. What's funny about this is two things. One is that this person should have noticed it as it was happening. Two, his disconnect between, well, it actually is a big thing. Although I've had in the software world, I've had people tell me, oh, you got this reverse, you can fix it, it's no problem at all. Now, actually, I was able to. So this is kind of interesting. In the software world, if you see, if I watch in the physical world while this is being built, you can see it. In the software world, here, let me pull this down so you can see my hands. I've done studies and I've studied watching developers creating code that was bug free. This is what it looks like. And then I did studies watching developers create code that had a lot of bugs in it. And this is what it looks like. I'm making a joke. In other words, you can't tell by the programming activity, whereas here you can tell by the programming activity. So in software, you have to create a way to see what's going on, and that is why you have daily stand-ups. That's why you have retros, why you have showing people. That creates visibility. But now here's the flip. We have to create visibility. We can create reversibility, whereas in the physical world, that's difficult. Susan, you looked like you had something to add.
I just wanted to add that I've never heard of a construction project that started out as a bridge and wound up as a skyscraper, but I've
Yeah.
seen software projects that made that big of a change.
Oh, I love you say that. And the reason is because they knew what the objective of their project was, and
Yes.
that was not because it was physical. That was because they took the time to do it. That's where I talk about jobs to be done. We have Amplio has three different pieces here when it comes to the requirements model. The first one is this jobs to be done attitude. Now, out of that, you define things with what I call requirements by objectives. By the way, I think I've got all of these. I think I've got all of these videos. If you go to Success Engineering, my website. So just successengineering.works, and then you go to resources and presentations and events. I did something on quickest valuable releases, and I did something on requirements by objectives, and this jobs to be done. I guess I need to do something on jobs to be done. I've done it inside the ACE program. I haven't done it publicly yet, but I probably will before too long. But most people, when they develop products, they don't bother with the objectives. What they're looking for, first of all, they figure they can't. They go to wants and needs.
Mhm.
And the problem with wants and needs is that you're talking to customers about what they want and need. Customers aren't very good at this. See, so here's what happened. Boy, this is amazing. I found this slide just like that. So we got to recognize we don't think and talk about what we see what we're able to think and talk about. Edgar Schein talks about this. So we talk about functions and wants and needs. And what happens is we start someplace and then we get some information, we get some feedback, and we wander all around the place until we finally get to the release. But had we have gotten the objectives to begin with, we could have started inside this and not wasted our time. Consuming stakeholders, whoever that is, we should be able to discover this up front. The other problem with the agile approach is it focuses so much on the user instead of all of these people. So at the release, we realize, oh, we forgot about this federal government thing we've got to deal with, or we forgot about the maintenance people, or all this. So software is a different problem, and this is one of the biggest problems with the agile space. Is it originated from a team that was given a task to build something. Scrum was inspired by the new product development game. And in the new product development game is, how do I build new products? I've been given this. You got to build this product. How did I discover that? It's not talked about. Rather, within the circle of the solution, I'm now enabling it to figure out what to do. Now, Toyota went beyond this, by the way, but that's not what I've seen in the other place. Toyota had this idea of the chief engineer, which is not present in most places, certainly not present in Agile, not present in most even other countries. The chief engineer was somebody who understood what was needed. He didn't say they took a job to be done, but I just got this. This is such a perfect example of it. So when they were building the first Toyota minivan, maybe it wasn't the first one, might have been the second one. The first one wasn't that successful. The chief engineer was told, we want this minivan, and this is what we want it to do. And he didn't agree with that. Why? Because the minivan, as he was told to build it, wasn't going to do what people who wanted a minivan to do. And how did he know that? Because he had watched people with minivans, and what did they do? They loaded 4x8 plywood into their minivan, and it doesn't fit. They put it on top of their car. They put it on another minivan. It didn't fit. So he told the people what he wanted done, and they said, no, this is what we want. And so then he went around the United States, because it's target US product. And he took pictures in every state of people putting plywood on top of their car or on top of their smaller minivan. And it convinced the executives. The job to be done of a minivan, they had two jobs. Good suburban housewife thing or whoever, or move plywood. That's where jobs to be done. And that's where the innovation came from. Then you had these big SUVs, then an SUV. What was an SUV about? It wasn't just a minivan. Now it had to have two jobs, be a family transport vehicle and a hardware vehicle. Those were the jobs to be done. If you look at innovation, there's always a jobs to be done, but it always comes from understanding the customer. And we don't bother to do that. Why? Well, you can say, oh, it's because there's all this pressure. You can blame, you see all these people in promoting agile methods blaming executives. Okay. Well, you're not doing it either. So why are you blaming them for not letting you do it? We're in this victim. Sorry, I'm getting on a rant here. It's just, but it really is the core for things. Yesterday, it was like I kept seeing these posts about how you can't do this and you can't do that instead of saying, and when somebody says you can do it, they don't say why you can, how you can, which is what I would ask. They call you a liar. I've been called liar so many times. I've been called serial adopter. I've been called so many names, but I've never asked, how did you do it? Well, you guys ask me, but not by those people. So yeah, I guess I've hit a certain level here. See, because this is relevant, because AI, and then I'm going to stop and get another question. Everybody's talking about what AI is going to do. There's no question AI is going to cut a lot of jobs. And there's no question we're going to develop stuff faster. But we're still taking the wrong approach, doing something wrong faster. Because jobs to be done is not being done. This is very critical. Yeah, Susan.
It just occurred to me that given complexity is more of a perception problem, that a lot of organizations add to their own complexity by, first of all, picking bad metrics because they're easy and the tool gives them or whatever, then building a dashboard out of them. So they've actually obscured what they can see about their own organization.
That is correct. Yeah, and when you throw in this, let's see, sorry, when you throw in when you throw this in, that wasn't it. I wanted, there was another one. Oh, here it is. This is the one I want. I've got a lot of variants on this quote because we're all looking under the lamppost. Okay, but what it means is if it's not in our vernacular, which you just mentioned, because I now have this dashboard. So if it's not on the dashboard, I don't see it. That's another way to say it because I don't see it. I don't see it. I'm not talking about it. We don't think and talk about what we see. We see what we're able to think and talk about. And when we make a dashboard, then that's what we're going to be thinking and talking about. And this other stuff, as you mentioned, we don't see anymore. It obscures.
And this is also probably why in so many organizations there that have, tons of data administrators and all that, there are a critical spreadsheet that exists on somebody's PC that are used for things like reporting numbers to the street and managing the business, and they're not in their nicely controlled data environments because nobody's understood exactly what's needed.
Yeah. And if you think about it from a microscopic level of a feature or a story and then try to build up the big picture, you can't. Then you're getting feedback from the customer. So when I talked about feedback, excuse me, be clear, I'm meaning feedback in the work process and feedback in terms of what the customer thinks. See, what people forget with XP, and it was also kind of a pipe dream. I mean, I love XP, but there was one thing about XP that I said you're not going to get, and you can't demand it. But I didn't totally understand the real limitation at the same time. XP, one of the practices of XP is to have an on-site customer. People tend to forget that. And the importance of XP, they also had this practice that even Ken Beck said they never could quite figure out how to say what they meant, was the metaphor. And what he meant by that was really I knew what he meant, but I was in the XP camp. I mean, I was early, I was into XP almost within the year it started anyway. And I really was big in it. not leading it, I mean active in it. But one of the things they talked about was the metaphor. And what the metaphor was really was another statement of what's the objective? What are we really trying to accomplish? Not what are these little things. So when you have a customer who knows what they want, they could guide you in the objective, especially if you're building it in little pieces. But once XP, because it couldn't have on-site customers, once it got into companies where on-site customers weren't there, you had this problem. Now I got close to the on-site customer when I built software. Actually, I didn't have an on-site. I went on-site. What I would do is sometimes I built custom software. I mean, I'd build it like something for a particular company. This was in the 80s and a lot of systems hadn't been built yet. So I went in and it was worth it for them for me to pay me to build it. And then what I would do is I'd spend a lot of time at my customer. In fact, one time I was at a customer, I was building so much of their stuff, they gave me an office in their building. I didn't only do work for them, but that way I was around all the time. But the other thing I did was if I was writing a product for hundreds of people, because I wrote that kind of software as well, what I would do is, well, hundreds of people don't really want to be bugged by me. I don't have the time anyway. So what I would do is I would find a few people who wanted to be involved. And this is where you appeal to people's egos. This is why when people tell me you can't get customers to give you quick feedback because they're busy, he says, well, you don't know how. What I did is I knew some of these customers because I'd worked with them, and I knew some of them like to feel, who doesn't like to feel a little smarter, a little better, a little more important than other people? So I would talk to them in a way like I really wanted their advice. And I picked the ones I really did want their advice. So I was being manipulative a little bit, but it was for their benefit and my benefit. I don't see anything wrong with it. And I would appeal to their better nature or maybe worse nature of ego. And I always had 3 or 4 or 5 people that I could run ideas by them anytime I wanted to. You just have to know people. Oh my goodness, aren't we doing the business of helping people? Isn't it worth knowing how people react to requests? Yeah, you don't hear about this stuff. I mean, this stuff that was happening 40 years ago. Anyway, so I don't know why I'm in such a rainy mood today. I think it's because of all that negativity on LinkedIn I got yesterday. People saying, you can't do this, you can't do this, you can't do this. And I'm like, please stop that. Saying, I don't know how to do this. Does somebody else know how to do this? That would be a powerful conversation. Okay, other questions? We didn't take our break, but that's fine. We can just keep going.
Well, to follow on with that one, or
Yes.
even if you say something is possible and somebody says, I've never been able to do that, tell me more.
Yeah, and you know what you might find out is one of two things. You might find out that what you thought was possible all over is not possible all over, and it isn't possible where they are. And what's happened is now the person who said it's possible recognizes the constraints. Or the other person may see, oh, it is possible here. I hadn't thought about it. Or you might get somewhere in the middle. But either way, you've learned something. See, this is what I like about lean. The number one thing about lean is continuous learning. If I had to say, what is lean about? I only got one thing to say it's about continual learning. Yeah. Tony, do you have a question? Yeah, you're on mute.
I'm just going to say, if you can replace the blanket statement, you can't do that and replace it with a what's the term? Uh, Communication, a dialogue. So you could say, well, why isn't it possible? If you have the time to engage in that conversation.
Yeah,
But it's
now,
a way. It's a replace the negativity with an actual dialogue, and it might. I don't know. The other person might say, "Well, I didn't think of that," or "I didn't think of the actual details."
yeah, there are some things you cannot do in the physical world. These are, called the laws of physics and things like that. But in the software world, there are also laws of, I think it was Wolfram Mueller mentioned, they called it the physics of flow. Like there is some limit as to how much work you can give on people. You cannot violate that. These are first principles. So learn first principles. Those are things that are inviolate. Don't violate those. But if it's not a first principle, and I'll give you an example of actually, again, I was going to pull up a sheet, but let me just go to success engineering here. Oh, I'm already up here. Okay, how about that? Go to Amplio University and the curriculum, and first principles are bound to be under the foundations. And there you got, verifiable first principles. I don't challenge, I request. People tell me where I'm wrong on these first principles. And I don't know if here's a quick statement of selected. I say selected because there are more than 10. Don Reinertson lays out 173 principles in his book, Principles of Product Development Flow, but not all of them are first principles. So, like, delays in workflow cause waste due to multitasking, yes. But you can build off this and make implications of this. Those would be guidance or secondary principles. Not everything is a first principle. First principle is something that stands on its own. The Agile Manifesto does not have first principles in it. I'm not sure there's any first principle in the Agile Manifesto. There are some values and there are some principles as in the form of guidance. And that's part of the problem with it. And some of the guidance, I think, and values are actually wrong. That's another issue, but that usually causes a lot of upset to people when we talk about it. I'm not alone in this one either, by the way. Okay, still got 13 minutes. Trying to think if there is something else. But see how much attitude is present. See, this is, by the way, something I highly recommend reading, and I highly request you challenge me on it. It's Amplio's Axioms. This is like my manifesto, you could say, in a sense. And I've listed them, right here. This is what I base Amplio on. We're here to create value. To do that, we have to attend to their values, success criteria, and constraints. That may not be what they asked for, by the way.
Yes.
Because they may not know. They don't think the way we could. We got to diagnose the situation before we pursue solutions. This is so obvious, but so violated. It's really kind of remarkable. I just got to show this. I love this picture I came up with. These four are how, if doctors were trained in Agile, how they would be. These are doctor frameworks. Not everybody is this, but all the popular frameworks are. Coming back. Inherent simplicity, cause effects of the system. See, I believe this is possible. I have evidence for it. It's an axiom. It's part of my belief. We increase our understanding of reality by building and evaluating our models based on our experience. Scientific approach. These are not fixed. This is where I talk about the penta. By the way, if you haven't seen it, I have created a good, better description. I can always improve, I know. But I did something on the penta if you missed it. This is a lot clearer on how to do this design I talk about. This is the penta. So that is up there. How simple an approach is designed is not as important as how simple and effective it is to be used. I mean, again, it's how the idea that a simply designed thing so you don't overload people, while a better system would be something that exposes you to something simple and gives you what you need after that. Theory work together. People don't inherently resist change, and people learn in stages. Then I go into it in detail. And most of these, not all of them, I'm still writing, have a lot more on them. Okay, other questions? By the way, anyone listening here is thinking the purpose of Q&A is not just about Amplio, but if you've got a real problem, tell me, hey, how would I solve this problem? I don't understand it. That's open. Anybody listening to this video, 3 Q&A sessions a week. I'm open for you. This is how I learn to help people, is by helping them with their challenges.
So we have a kind of challenge, but I mean, it's just like to let you know, it's not like asking help because actually we are figuring out what to do. But talking about predictability, we detected that we are actually predictable because since like 1 year ago, every single quarter we planned something, a bunch of initiatives, and we fulfill and we complete just half.
Yeah, so
It's like kind of joke because it's sad because the manager thought at the last quarter closing, he said, "Hey, 1 year ago and we're still the same. We planned and we execute only the house. We planned, we still design." And thinking about it, I got to the conclusion that we are predictable. We always plan like
yeah, it's
this and we
funny. Your
execute
work's
half.
not predictable. Goldratt would
Yeah.
say that. Your work's not predictable, maybe, but you are predictable. Yeah, we had a massive breakthrough with a major bank. We were working with one of the top 5 banks. This was back in 2007, something like that, 2008. And one of our guys was meeting with all the executives. It wasn't the whole bank, it was retail. Banks are broken up into different groups. And what's called retail is like the bank, where you go in and you walk in and your checking account, saving accounts, that's called retail there. And he's meeting with all the executives, the top product managers, program managers, whatever. And they looked at the number of things that were budgeting for the year. So 2 things that were, I thought, really brilliant, he said. So they said, well, we're here to figure out budgeting. And he asked a question. He said, are you hiring more people? And they said, no. Are you building any new buildings? I said, no. Are you expanding anything? I said, no. Oh, so we're not talking about budgeting. That's set. You're talking about how are you allocating the funds you have to things. So first of all, you got to know that's what's going on. We're not budgeting. We've already got our budget. We're trying to figure out how to allocate funds. So the next question he asked was, how many different products, things, enhancements do you have on the list? And they said 250. So then he asked, that seemed to him to be a high number. So he asked, how many did you do last year? And they said 50. Doesn't 250 seem a little high? He said, you're spending all this time figuring all this out and you're just wasting your time because they're not getting done. So he made his point, and in fact, by the end of the week, they got down to 75, which was still more than a beyond budgeting approach. But I'll tell you, going from 250 to 75, and this is at the executive level.
Mm-hmm.
This is not, see, the problem is executives can understand it when you talk about it from the value level, not from the feature or story level, not from the team level. So they don't understand the obvious because you're not giving them what's important. So then the question becomes, well, can we predict? Okay, I've driven in foggy, in big fog. I mean, where you cannot see very far ahead. I've driven on icy roads. I never got into an accident on an icy road. I never got into an accident on foggy roads. Even though you would say, well, it was visibly impaired. Of course it was. I lived within the visibility impairment. I did not go 60 miles an hour. You look at these big collisions where 50 cars are involved because of fog. It's because they're driving beyond what they can see. That's insane. You know what's going to happen, but they do it anyway. I lived in Cambridge for 2 years when I was at MIT. Cambridge is across the river from Boston. And it was really weird because this was the first time I'd lived in a place that had ice and snow on a regular basis. And so I get up there in the fall and it gets snowy and icy and it's not that bad. But the first 3-4 days, accidents all over the place. The worst ones are those people who have 4-wheel drive. What they forget is everybody has 4-wheel stop. And that doesn't work too well. So what I did is I stayed off the roads for a week. I was fortunate I could walk or take side roads, or I rode a unicycle, believe it or not, into campus. But I would not get on the main road. And after a week, and I made a comment to somebody, said, oh yeah, every year this happens. They forget. So humans are designed to mess up in that way, you can say. So what you want to look at, this is where beyond budgeting comes in. Beyond budgeting says, don't plan way far out, because when you do, you're planning beyond your visibility. So they take it beyond budgeting is brilliant, but in the United States, I think it'd be difficult. Europe handles beyond budgeting, and Scandinavia handles beyond budgeting a lot better. It's actually where it started, and it's not by industry, it's by culture. Because where it started was with people like banks and oil companies and things like that. People have very heavy capital investiture, and you would think would not be interested in like every 3 months, or and not even having like finding out what's the next best thing to do. They had strategies, yes, but they didn't allocate the funds. This is where in Amplio, and I'm going to put it on the schedule when a couple of people from who are in Australia, it's got to be in the afternoon. I've got them tied up. That's why we talk about agile budgeting and lean allocation. The budget can be out for a while, but you don't allocate funds. You separate allocation and budgeting from each other. Yeah, Thomas.
Yeah, there can be industries though where the planning horizon is heavily influenced by government, sort of like tax credits, for example, and government policies. And for example, in the power industry, utilities, right, when they plan to build a new power plant, those things, the amortization of that is measured in decades. So
Yes.
nobody can foresee what's going to happen in 20 or 30 years. But the plans will be based on models that go that far and that
Right.
then assume that you have these tax credits for at least, I don't know, 10 years or something.
Well,
So
I'm sorry. Yeah.
it's the time horizon is often influenced by many of these other stakeholders, like constraining stakeholders or sponsoring stakeholders. So not all of that is within our control as the development team.
That's correct. So there are 2 points here. One point is you have to know what your constraints are and live within them. And the other one is notice how the viability of the constraints change the whole investment.
Mhm.
This is why some level of stability in economics is so important. I'm gonna cross my own line about politics. It's why the whole tariff thing is so insane, because it's introduced instability in a place where you need stability to make long-term investments. And this is what's killing a lot of things now. People are stopping investing, not because of the tariffs, but because of the instability of the way tariffs are being done. These are factors you have to attend to. All the disasters that are starting to happen now, and believe me, it hadn't even really started. Wait until Canada doesn't ship us any more oil and other things happen. See, you could say that this stuff was unpredictable, but actually, if you took a systems thinking point of view and didn't think, oh, we'll just do one little nuance and change it and then I'll control everything. See, that's where you get these crazy results. And it's interesting because I've said this, I wrote actually a post about how we could have improved manufacturing in the US. It simply changed the tax law. So investment happens as an expense because that lowers the risk. If I spend the money and I get
Yes.
my tax break immediately, then if things do change, well, at least I got my money back now.
Yes.
But it's a simple change that actually affects everything else. But no, not if you want drama. It's kind of interesting because I think the United States government is mirroring the way all the bad stuff in companies that everybody rants against. It's something to look at if you can stand it. Um, and these there's all these points of how far can I see? How can I see further is another question. So good. That's actually a good question there. So whenever there's a constraint, you have to ask, can I violate this constraint? Not can I violate, that's not it. Like how far can I see? Or I've got limited visibility, then you should ask, how can I see further? Now there are some things you can't violate. See, one of the beauties of physics is it explains that there are things that are inviolate. Now, maybe 20 years from now, 100 years from now, we'll get past them. But I'm pretty sure the laws of thermodynamics are not going to be found to not happen. Okay, or we're going to have to learn a whole bunch of stuff. I don't worry about the laws of thermodynamics when I'm trying something. I pretty much that's inviolate. Every now and then it's worth challenging our assumptions, but there are constraints out there that we should have confidence in. Okay. Any other questions? I can hang a couple extra minutes, not too much longer because they need more coffee, but. So yeah, okay, good. So this to me is one of the big things because it's an empowerment of that we can make a difference and we use what we know to move forward. And I would suggest I would suggest that it's lack of thinking we can do things that causes a lot of the nonsense in the agile space because people get
Yes.
demotivated and they give up. And that's a real problem. Okay, well, I'm going to close this. I'm going to stop the recording. I found if I don't cause the recording,